not only for the, most of the time we give the answer like that is only for the binary problem, but we can also use this thing in the as a multinomial logistic regression. But somehow the concept is same. Only we will change the functions, or you can say the loss function. In the last class, you have already seen for the logistic regression, you use this type of loss function. This was the loss function for the binary logistic function. You got the, that is the data is m, you can say m rows is given to you, that you can use the y log I predicted plus y minus 1 minus y log 1 minus y predicted. This was the loss function. I have told you how you are getting this part, and you use this thing, this predicted thing here, that is the sigmoid function. You know very well. This is the sigmoid function you used in your logistic regression. Yes. So story was like this. If you understand like this, you are finding first what is you are doing. You have some data. Data means something x and y is given to you like this, and you are putting in equation of some y predicted, that is wtx plus b. This is the equation of line. So this thing you are doing in the regression part also. Yes. Tell me yes or no. So you have done means you are finding this equation in the regression also. Yes or no? Please reply. कोई बोल नहीं रहा, सुनाई दे रहा है ना, मेरी आवाज आ रही है? हेलो विशाल,
सुनाई दे रहा है,
सॉरी,
ये सर सुनाई दे रहा है।
यस, ओके, तो यस नो तो बोलते रहो, मैं पूछ रहा हूँ. So that was the confusion actually. Okay. So what is happening? You are finding the equation by the regression. After that, what you are doing? You are putting this value, whatever the y bar value you are, sorry, what is the equation of this line you are putting in the function, sigmoid function. Okay, this sigmoid function. So what is happening? This 1 plus e to the power minus wtx plus b. So what is happening? This is the regression thing, and this is the logistic or sigmoid function. Logistic. So you can say by the combination of this logistic and regression, you call this is the logistic regression. Last time I asked you why we are calling this the logistic regression, even though this is the classification problem. Okay, but we are using the regression to put in the sigmoid or logistic function. After that, we will get some output, and we see that if the value is greater than 0.5, we can say this is a 1, and lesser than 0.5, we can say that is a 0. This is the story. So you can predict the classification on the basis of this regression and the logistic function. That's why we are saying this is the logistic regression. This is the reason to nomenclature of this regression, logistic regression. That part is clear to everyone? Yes or no? Yes?
Yes.
Okay. But in
Yes
between,
sir.
I have told, yeah, in between, I have told you, you can use this type of loss function to find out the logistic regression, and we are using this function. Okay. Now the story is changed. What is happening? That was for the only binary classification. But if you have the more classes than one, what will happen? Okay. So you can understand, again, I am taking the same example. So you have some CGPA of a student, you have some IQ of a student, and you have the placement. Placement means one, you can understand, that is placement is okay, means yes. Okay, two, for you can understand that placement is not happening, that is no. And third one means student is not opting for the placement. Okay, so not opting, or you can say opt out, means he or she is not even concerned about the placement. So three types of data. Now the output or label data has the three classes. Okay, 1, 2, and 3 somehow. So you can say I am taking the example. So this is CGPI is 8, IQ is 120, but the placement is going on. Okay, so इस बच्चे का placement हुआ है, इसका नहीं हुआ, और इसके opt out किया है somehow. So this is the data. This data will giving to you. Now I will tell you, I will ask you, just use the logistic regression on this data. So how you can do this thing. So now I just want to tell you how can you do this part. Okay, even the problem is multinomial, but you can use the logistic regression to find out the output. Yes. So first step is you will do the one hot encoding at the output level or the, okay, this is the placement. So you can say this is the output level, classes are three. So you will use the one hot encoding. One hot encoding सबको पता है? Yes or no? What you can do, for yes, I am taking this DA. For no, I am taking this DB, and for opt out, I am taking this DC. Okay, so what is happening? If the placement is going on, I am put only one in this place. In other places, I am putting zero. Everyone is clear on this point? Please reply.
Yes, sir. Yes, sir.
Okay. फास्ट तो नहीं जा रहा हूँ? ठीक है, समझ आ रहा है ना? थोड़ा लिखा हुआ पहले से है, नहीं तो पहले मैं लिखता था, तो फास्ट तो नहीं है, अंडरस्टैंडेबल है?
हाँ,
बोल
अंडरस्टैंडेबल
दो
है।
यार। ओके ओके, एक ही बच्चा बोल रहा है बार बार, दूसरे भी कभी कभी बोल दिया करो। एनीवेज, okay, now in the second part, you can see some input data is given to you and this is ranked, that is labeled with 2. So you can say this is no. So only one will come here and other places you are finding that is the 0 and 0. So with the one hot encoding, this type of data you can generate. So this time you have the different outputs. How many classes are there? You have to put this number here. So all these are output. अगर आपका 4 होता 5 होता labeled, then you have to put DA, DB, DC, whatever. So till that number. So everywhere you can go for the one hot encoding and you can do this part. So first thing is clear. What we are doing in the multinomial logistic regression, you have to convert this class by using one hot encoding in different classes. Clear? Whatever the number classes number is given, you have to make the output like that. Already you have done this thing in the that regression problem, that polynomial regression problem, but that time you are using the input level. Okay, in the input level, what you are doing, that is the x cube power 0, x cube power 1, x power 2, you are doing at the input level. But now for the logistic multinomial logistic regression, what you are doing, at the output level you are doing the same work. Everyone is clear? Okay. So after, very good. After getting this, you can see, sir, now I have different data. What? Sir, in the one column I have the CGPI, in the one column I have the IQ label, and one column you can use this DA for the yes. Okay. So third, one type of data you can generate, this thing is one type. ओके, वन क्लास एक आपका ये डेटा जनरेट हो गया. सेकंड, सर अगेन आई एम यूजिंग सीजीपीआई आईक्यू, बट आई एम आउटपुट आई एम टेकिंग दिस वन, दैट इज फॉर नो. ओके, सो दूसरा आपका डेटा ये रेडी हो गया. थर्ड डेटा यू कैन से सर सीजीपीआई आईक्यू एंड द लास्ट वन. Okay, so three classes, three data we have ready. You can say that is the M1, M2, and M3. Now just think, that is the common sense. Now you have, this is the input data, this is the input data, only one is output. Everyone is clear on this point for M1? Yes. Now
Yes,
easily
sir.
you can use the, yeah, now easily you can use the logistic regression for that. Yes or no?
Yes.
Because same you are doing in the logistic regression. What? One output is there and some data is there. Input data is there. You can use the logistic regression. So some output you will get, but try to understand what is happening. Now think this thing. The CGPI is here, IQ is here, and DA is here. So what is happening when DA will be ready? So DAs look like 1, 0, 0 and something. So what we are saying, sir, at this data, the placement is happening. Yes, I don't know for these students. These are not selected or opted out. I don't know. Even maybe these are not selected or this is opt out. Okay. I know only this is selected. Okay. For these two classes, I can't take the decision directly. Yes or no? Everyone is getting this point? Now, same
Yes.
exercise for DB. Same exercise for DB. What will happen? If I am taking this is the DB, what is happening? This is not selected, but I can't say this is yes or opt out. Yes, everyone is clear on this point.
Yes.
Yes, good. For third part is also this part is that is opt out, but I don't know this is not selected or selected. Okay, so you have converted what we are doing here. You can understand, yeah, by common sense you can see we have converted the multinomial problem into the binary logistic problem. Yes, yes or no? Means if I am taking this class,
Yes,
only
sir.
1 or 0 is there. For this class, 1 is 0 is there. For this class, 1 or 0 is there. So three different scenarios I have taken for this thing. I have converted this problem into the binary problem. And I can use this formula and I can attempt this question. Yes. So the behind of the story, this will happening. Yes, but sometime we can use directly the formula, or when you will use the libraries of this sklearn or something, we can go for directly things. So where then what is happening? Actually, the thing is that till now you're using this formula for the binary thing. Now this formula will be converted into the softmax. When you are working on the multinomial logistic regression, instead of sigmoid function, you will use this type of softmax function. Okay. So this softmax function, what is there? E to the power ez, and this is k is the class. K is the class number of classes. So by this formula, directly you can attempt this, not this thing. You will use this part. Okay. And instead of that loss function, you will use this loss function. Even though the same interpretation is coming, this loss function is coming from this loss function only. Okay, but now I am not going into the detail of this thing. You can use this part for the multinomial logistic regression. So what is happening this time? You will use the function, this softmax function, and this loss function, and the same procedure you will apply. You will get your answer according to. Yes. So this is the story, but behind the story, you can understand every time what you are doing, you are converting the problem into the binary problem, and after that you are taking some summation or whatever, and you are getting. So directly when you are applying the library, you can directly use this loss function and this thing. Even though if you want to see, means, sir, if you want to calculate this part, I can take one example, try to understand. That is कि मैं एक एग्जांपल x1 है, x2 that is the input part, and again y के लिए मैं वही ये iq है, ये cgpi है, तो 1 2 3. Okay, same thing I am taking, and this is for yk is equal to 1 के लिए, yk is equal to 2 के लिए, and yk is equal to 3 के लिए. So you can say, sir, this one 1 0 0, this will 1, this is 0 0, this is 0 0 1. It will happen, yes or no? ओके. सो वॉट एवर द नंबर इनपुट मैं अभी रैंडम मान लेता हूँ, 1 1 1 2, दिस इज 1 2, सॉरी, ये आ जाएगा 2 1, और दिस इज 2 2. ओके, वॉट एवर द गिवन टू यू. सो नाउ यू कैन कैलकुलेट लॉस फंक्शन. अगर मैं निकालूं दिस 1/m, अभी ऐसे रख देता हूँ, i इज इक्वल टू 1 to m, अभी लेता हूँ 3 ले रहा हूँ, डेटा कितना भी हो सकता है. सो यू कैन m आई एम पुटिंग हियर. नाउ द k वैल्यू you can put here. K is equal to 1. For this thing I am taking. So classes is 3. Okay. Okay, put this value. K is equal to 1. I can put this thing. Yes. Okay. And this is I. For first line, I am using this thing. Okay, so this is 1. Now log y1. This is the predicted one. Sorry. Okay, this is the predicted one. Now you can see if I will use this formula 1. Okay, here. So directly it will come 1. Okay, somehow. ओके, सब सभी लिख ले रहा हूँ. यहाँ पे आ जाएगा आपका 2 1 प्लस लॉग 2 1 और प्लस y3 1 लॉग 3, 1. Okay, now you can see if I put this value, so this will work because your answer is 1 here directly by predicted 1. Now log 0, this is the y. So what will happen this prediction thing? Because the second part, this thing will be 0 because y2 value will come 0 here, y3 value will come 0 here. Only you will get this thing, this input and this part. So again and again, when you will get the formula, all other term will be 0, only this term will be remained. So same story is there, means you are doing the same thing. You are dividing the thing by this formula or function. Why this function you are dividing means you have created the three classes, one class, two class, and three class, and you are taking the only one class where it is coming. The same story is going on with the formula. So directly you can use this formula or this function to attempt this type of multinomial logistic regression. Is it clear to everyone? Yes, please. So
Yes,
never
sir.
you can, yeah, never you
Yes,
can
sir.
say logis. Oh, very good. So you can say every time you are going for only the binary thing. You can attempt the question with the multinomial logistic regression. So if their class is more, even though you can attempt this part. Okay. So remember only two things. If you forget all these things, the functions and the loss function. Which type of function you are using? In the binary, you are using the sigmoid function and this type of loss function, and the multinomial you are using this type of loss function and you are using the softmax. Sometimes you will find the name of the multinomial logistic regression is the softmax logistic regression. Okay, logistic regression. And the answer is clear why we are saying the logistic regression, why we are not saying that is the logistic algorithm or whatever. Why we are using the word regression, even though regression is only for the predictions. So first we predict and we are giving to the some function, and after that I am classifying. Okay, so that's why this is classification problem, but the nomenclature is regression also. Everyone is clear on this point? Yes. अगर ये क्लियर है तो मैं आगे बढ़ता हूँ. Everyone is clear? Okay. But in the last class, I think everyone is know this fact. What I am telling you, when you are using the logistic regression, one thing is there. The problem should be linearly separable. Yes, everyone is know this part. The problem should be linearly separable. So
Yes.
what I am saying, if the data is look like this, some data is here and some data is here. Sorry, ये तो काम ही नहीं कर. Okay, some data is here. So if this linearly separable, you can do this exercise with the logistic. But data, if the data is looking like that, means somehow, okay, and this type of data. So this data is green is one class and this red is one class. So this data is not means separable by the linearly. Even though we can do some exercise, we can make this data as a linear. We can go for the hyperplane and we can convert this data into other domain. वो हम SVM में करते हैं कि इस डेटा को एक हाइपर प्लेन में भेज देते हैं तो वहां ये डेटा लीनियरली दिखने लगेगा. ये ग्रीन को हम यहाँ पे देखेंगे और रेड को यहाँ देखेंगे और linearly separable कर लेते हैं. But that is the other story. Till now, you know that is the logistic regression and linearly data is not, sorry, non-linear data is not means taking care with the logistic regression. Clear? Everyone is clear? And when I
Yes.
started this thing, logistic regression, I told you about the perceptron trick. Yes, perceptron trick. So in that trick, so this perceptron is coming again. I am coming back this perceptron is coming from the some biological thing. Okay, so you can say that is the neuron. So neuron in the biological part in your brain and the perceptron in the artificial neural network. So you can say neuron, you can use the word neuron for the biological neural network. Okay, biological neural network, and perceptron word you can use the artificial neural network. These are the same thing. So again, I am not taking the terminology कि वो किससे match करता है क्या करता है. Just I am making a graph thing and try to make you understand what is happening. So in this trick, what is happening? Some input you have means x1, x2, and some bias. You can say this is the bias B, or I am taking 1, and you are get what was the equation? Just मुझे यहाँ बताओ आपकी equation क्या थी यहाँ पे. याद हो किसी को? w1 x1 w2 x2 plus some bias is equal to 0. So we are taking this line as a 0.5 line. The probability of that line was the, मैंने क्या कहा था कि ये कोई line है, यहाँ कोई data है. So the probability of this line was the 0.5. उसके ऊपर वाला greater than 0.5 था, उसके lower 0.5 से कम था. So again, this line is coming. So you can say this x1, this x2, and some bias we are taking. Okay. Now it is attached with some weight. So you can see some weight 1 मान लेता हूँ. So I can put here that is the 1, weight v का 1 है. Second x2, that is you can take w2, and this is w1. And somewhere what is happening? The summation is happening here. Okay, the summation is happening, so you can put some summation. Yes, after that, okay, यही स्टोरी आपने ये इक्वेशन बनाई. अभी लॉजिस्टिक रिग्रेशन में मैंने आपसे क्या कहा? Just I am removing this part because I am relating this thing. Try to understand what I am saying. To you have data and you are finding the equation wtx plus b. Same, I can write this thing like this, w2x2 plus b. So you are finding this thing. Till now you have finding. This part is okay because यहाँ summation करोगे x1 w1 x2 w2 and b into b is equal to not 1. I am taking this b. So same equation you are finding till now. Yes, everyone is with me? Yes or no? Yes, sir. This
Yes,
is the
sir.
data. Okay. Now what you are doing, you are putting this thing in the sigmoid function. In the logistic regression में यही करें, sigmoid में आपने provide किया था. Now I can take that is some threshold, or you can say some function. Okay, so I can make this type of thing. Okay, sigmoid हम अभी बना दे रहे हैं, या फिर you can say some function. यहाँ पे actually क्या है कि that is biological perceptron use only for the step thing. Step का भी मैंने बताया था. Step means either you can take 1 or either you can take 0. So this is the step graph. Okay, so first I am taking the step function here. So step function means this function. Okay, even though you can take sigmoid or whatever, no problem, or you can say sub-sigmoid function I am taking. So what is happening? What is the value of this equation? यहाँ से आपका 50,000 भी आंसर आ गया. If you are putting in the sigmoid function, what is the answer? 50,000 इस वैल्यू का. ये अगर x is equal to 50,000 बोल दूं, ये x है. So what should be the answer? That is the output will be 1 or 0. Okay, so what is happening? Some input you are providing and some linearly summation is there. Then you are taking some threshold. So you are ranging the thing. I'm using word ranging. Means some ranging you are providing. Yes or no? Everyone is clear till now? So same thing you are doing in the perceptron. This is the basic unit for the ANN, artificial neural network, where you are using the input, you are summation that part, and you are providing that part into a function. On the basis of that, you are taking some decision. What should be the range? Okay, what should be the answer? Yes or no? Everyone is with me? Please, Hana to bol do.
Yes, sir.
Okay,
Yes, sir.
so again the same problem with the perceptron. ये मैंने पढ़ाया भी था. It can only use for the linearly separable thing. Linearly separable. If the data is not linearly separable, you can't use the perceptron alone. Otherwise, अब वो आप लोगों ने बहुत जगह जिसने ANN पढ़ा होगा, तो some example you can see that सबसे पहला एग्जांपल हम लोग ये लेते हैं एंड और को बनाते हैं एंड एक एक्स और को बनाते हैं. ओके, नाउ यू कैन अंडरस्टैंड बेटर. चलो मैं वो भी बता देता हूँ. एंड के किसी को टेबल याद है? दिस इज अ डिजिटल थिंग. 0 0 पे आपको ये मल्टीप्लाई की तरह समझ लो, अभी ये प्लस की तरह समझ लो. सो व्हाट इज द थिंग?
0 1 0
यस यस.
0 0 0 0 1 0 1 1.
Very good.
Say 1 1
Everyone
1.
know. I understand. Yeah, very good, yaar. Chalo. Okay, this is AB and Y. Okay, now I will show you the different aspect of this. यहाँ पे क्या आएगा? 0 1 1 1. ओके, अच्छा जोर का अगर मैं A जोर B करता हूँ, क्या आंसर होता है बताओ?
1 0 0.
Yeah, this is the formula, so you can find this is A, this is B, and this is A or B means 0 0 0 1 1 0 and 1 1. You can find this is the 0 0. This is 1. This is 1. This is the answer. Everyone is clear. Means जिसको mostly I believe इस सबको पता है. Okay, now I will put this values, this output. Okay, you can say this is the X, this is the Y, this is the X, this is the Y. At 0 0, what is the answer? 0. Okay, I am putting 0. At 0 1 0 1 means the answer is 0. Okay, this is the 1. And at 1 0 the answer is 0 again, and the 1 1 the answer is crossed. Yes, just a minute. Okay, sorry for interruption. Yeah. So what is going on? This type of graph you will get. Now you can see this data is linearly separable. This is the different type of data, this X. Yes, because this is the 1. Okay, or I can repeat this thing by this X. So you can say if I can take this line, okay, one class is there and second class is there. So I can, this is the binary separable data. You can say with the linear thing, I can separate this data. Everyone is clear on this point? Same if you will do this exercise, you will find कि आपका अगर same exercise करूं मैं, so what will happening here? At this point, this 0 0 is 0, other point is 1. This is cross and this is cross. So I can remove this thing, this one, this one. Okay. So this type of data, this is 1, this is 1, this is 1, and this is only the 0. Again, if you will get this thing, this line, so again, this data is linearly separable. Now I will talk about the XOR thing. Okay, what is happening in the XOR? So you just tell me this is X, this is Y. At the 0 0, the 0 is answer. Yeah, it is the 1 1, the 0 is answer. At the 0 1 0 1 here, that is a cross and the cross. So is this linearly separable data or not? Just tell me. Quick answer. Okay, so sir, you can say, sir, I can separate this data if I can take this line and this line. Yes?
Yeah.
Two separable lines. Try to understand where I am going. So if I can able to find out these two separable lines, this data will be in one class and बाहर का जो class बच गया वो एक class में आ जाएगा. Okay, this type I can separate this data, but with the only one line, I can't do this thing. Okay, so anyhow till now you can use the perceptron because perceptron only is the one unit and it will give you only the one equation. Yes, but for this you need two lines. Okay, two lines, so you need the two equation, or you can say that the two perceptron I need. Yes, that funda is clear to you. For this line I need one perceptron, for this line I need one perceptron. So anyhow the multiple perceptron, ठीक है, linear perceptron, you can say multiple perceptron theory will come because you are unable to do this separable thing for the non-linear data. This is the non-linear data, and I want to do this part because we are relating this thing with the human brain. So human brain is able to means classify the non-linear data also. So we are resembling this thing, but the concept of multiple neural network, yeah, you can say multiple neural network comes. Yes. So I will teach you first. So perceptron is clear to you. What is the means of perceptron? What is the unit of perceptron? So this is the perceptron thing. Now you will club the perceptron. More than one perceptron will come. And remember the thing, this will work. Every time when you are taking the word perceptron, it will only linearly separate the data. Okay, if this will be with you, then you can understand how the data is separable. Every time when you're using the word perceptron, one perceptron is there, only the data is linearly separable. Okay. Now I am coming for the second, you can say, now I am entering, you can say, in the multi-layer perceptron. Yes. So this is the MLP. Now I will give you the introduction and intuition, how you will use and why we are using this part, multiple layer perceptron. So first thing is clear, what is the perceptron and why we are using and how we are using. That part is clear. Okay.
Yes,
And
sir.
what is the relation between the logistic regression and the perceptron? That part is clear. The logistic regression look like perceptron. Okay. So now I'm coming to the intuition part. So already you have seen, if you have this type of data, you can perceptron learning, you can divide this data by the linear thing. Okay. Everyone is okay. So you can find a decision boundary like this and this data will be divided. Okay. And directly we can say you are with the perceptron, you are finding the line. Yes. Now, when we are using the more than one perceptron, we are trying to find out the curve, not only the linear line every time. This type of curve we are trying to find out because somehow you are seeing this part. Some data is here also. This red point is here also. Some red point is here also. If I am able to find out this type of curve, yes, then my learning will be more accurate, more accuracy will be there, more precision will be there. So how we will find this boundary? Okay, this decision boundary, that is the thing with the perceptron. That is clear. That part should be clear to you. Every time you can use only the perceptron. Yes. So your basic unit is perceptron. You can use the perceptron directly, but any other thing you can't use into the ANN. So how we will do this practice, you will learn. So till now you are with me. This PPT is means okay with you?
Yes.
Okay.
Yes, sir.
Okay. Okay. Now, so already you have seen this thing. I have taken one example. So this is bias. Again, I am taking the same example. I have IQ, I have CGPI, I have some bias. Okay, I am putting this value and I am first thing I am doing the summation part. Whatever the answer you can see. आंसर इसका क्या Z का आंसर क्या आएगा यू कैन सी सर जेड विल बी CGPI multiply with CGPA W1 is multiply with CGPA plus because it is a summation so W2 is multiplied with IQ and this one will be multiplied with B. The answer is Z. So Z is the answer. Now I am putting this answer into the sigmoid function. Okay. So this Z value will take whatever. Yeah. So you will take the Z value. Okay. So already I have told you whatever you will get that answer will be between the 0 and 1. So maybe you will get the 0.8 or 0.5, 0.6, whatever you are getting according to your data. So this is the story of the perceptron. On the basis of that, what may happen, you will get the answer. So again, this will be look like the logistic regression. This is the line. This is showing that is the probability 0.5 and the equation is of line is 5x. मैं एक example ले रहा हूँ. So this is the example. You have the uh, line of equation, that is the 5x, 10y, and 3. So W1, W2, and B is 5, 10, and 3. Okay. So you can linearly separable only by this method. This is the perceptron story. But what is the story? We need this type of curve. So how you will get this curve? Now I'm coming to that point. Okay. Try to
Sir,
understand
I
the
have a
story.
question.
Yeah, sure.
Sir, in this perceptron MLP, you are showing that linearly separable data by using that
Yes.
line equation. But sir,
Yeah.
in MLP, there will be some complex structures created. So how can
Yeah,
we
I am
get over
coming.
it?
Yeah,
Okay.
yeah. So I am coming on that part, how we are getting that complex structure. Till now, I am talking about the perceptron, only this thing. Okay, this part. Now I will make the more layers for this. Yes. So on the basis of that, we will get the answer of this thing. This type of data we will get. I am coming how we can generate this complex structure. Yes. So after this slide, I think I will get, if I will correct, your answer will be means okay. Will be you are getting the answer after this slide. Yes.
Okay, sir.
Okay, Neha.
Okay.
So
Okay,
wait
sir.
for this slide. Then again, if you have doubt, you can ask me. Yeah. Now, what is happening? Same, the data is here. What I am doing, the first perceptron is giving this answer. I am taking this line is giving this answer somehow. And second perceptron, a one more perceptron is giving this answer. What I am doing, I am adding these two perceptron thing. This perceptron and this perceptron, I am adding. First, I am adding. So what will happen? So you can go for the structure. This part is clear to you? With the one perceptron, I am getting this line. One perceptron, I am getting this line, and I want to add this two perceptron output.
Yes,
So
sir.
somehow, if I am saying this is the first perceptron, this is the second perceptron, the if you will adding this part, the answer will be look like this. Yes, this cross thing. Everyone is clear on this point?
Yes,
Yes or
sir.
no? Okay, very good. So what is happening here? Try to understand. I am taking one point here. This is the point. मैं इसका निकालना चाहता हूँ कि output क्या होगा. For the first perceptron, the probability is coming. That is the 0.7. For the same perceptron, in the second model, the probability is zero point 0.8. Yes. Now, if I am adding these two, you can say, sir, the probability is 1.5, but the probability should never to the one greater than 1. So what I am putting this value, whatever, if you are adding, I am putting this value in the sigmoid function. Okay. So this is the jet totally, whatever I am putting this value, somehow it is coming from 0.82. So what is happening? You are adding something. Okay, after that, you are trying to make this type of curve. That is the smoothing. So this function, what is doing? This is after adding, you are getting this type of thing, but this function is smoothing this part. Yes. So for the smoothing, you are putting this output into the sigmoid function. So two things you are doing, you are adding and you are smoothing. In the ANN term, what you can say, two linear perceptron you have some answers, you are doing the linear combinations, and after that you are putting in function, you can say that is the activation part. You are activate that part to get this type of curve, or you can say get this type of thing. So you're smoothing. So you can say, sir, every time what I am doing, I am taking the linear combination, and plus what I am doing, I am doing the activation part. Clear? Okay, so on the basis of that, you can say this is the answer. Yeah. Now, if I am talking about the complex structure, I am coming on that part. Before that, try to understand what is happening. Somehow, this is the one perceptron story. This is the line. This is the second perceptron story. This is the line, and I am adding this part. But somehow, I want to give the more weightage to the first perceptron, not this thing, because in the brain that is happening. Sometime one neuron has the more weightage to get the answer. So what we can do, we can multiply with some weights. So I am giving more weightage to first perceptron rather than the second one. I am getting some weightage less than the first one. Yes, I am adding this, but somehow what I am doing, I am giving some weightage. So you can say now this zero is, so whatever this ring, this is the one perceptron. This is the second ring. This is replicating the second perceptron, and I am giving some weightage to this one and this one, this W1 and this W2, and I am summation this part. I am summing or adding this part. So you are getting this type of story. Yes, everyone is with me.
Sir,
Try to
sir,
understand.
the weight.
Yeah.
Yeah, sir,
Yes.
the
Yes. Yes.
weightage value taken from the data set.
No, no, no. This, so I will tell you this part this time for the understanding purpose or intuition purpose. We have to adjust this part only. When we are
Okay.
getting the data in ANN, we are adjusting
Hmm.
this weightage only and bias. Okay. But this
Okay.
time for intuition purpose, you can understand that I am giving some more weightage to this thing and less weightage to this thing. This is W1 and this is W1 and this is W2. This is the perceptron. This is the one story. X1 is this and X2 is this. Yes. After that, I am adding this part. So you are getting this type of answer. So JAD value is giving to you. This is the JAD one. Okay. After that, I am
Okay.
putting in the A activation functions. So this is the activation function. So I am smoothing the curve. I can,
Okay.
किसी का mic खुला है, please stop the mic. Yeah. Otherwise, I have to take. अभी सभी बंद हो गए. Okay. Okay. So after smoothing, you are getting this thing. So please try to recall the perceptron. Perceptron में यहाँ पे directly input था. This is the CGPI. This is the IQ. This time this is not the CGPI and IQ. This time this is the output of this perceptron. Remember this thing. This zero you can see here. That is the perceptron. So one perceptron and the second perceptron. So this is a linear separable thing, and we have some weightage for this thing, the output of this perceptron, and again summation and again smoothing. So you are getting this story. Yeah. So you can see anyhow this data was not linearly separable, but we are making this data separable by some curve with the story of the some combination of the perceptron. Everyone is with me till now? Yes or no? Please reply. This part is okay to you? कोई और जवाब देगा कि नहीं? आज सभी म्यूट पे चले गए.
Yes, sir.
Yes, sir.
ओके. एनीवेज, चलो आगे बढ़ते हैं. तो अगर स्टोरी यहां तक समझ आई है, बिकॉज व्हाई वी आर डूइंग दिस पार्ट, try to understand every point is perceptron now. Okay, this and this. Now, okay, so if you will see the bigger picture of this diagram, so this diagram will be look like this. Okay, some CGPI is there, some IQ is there, some weightage is there, and this is the bias thing. Bias को मैंने अंदर ही लिखा है. This is the 6, this is the 3, and after that we are putting in the sigmoid function, and whatever the output is going, we can connect with the weightage. Okay, so this is the perceptron 1, this is the perceptron 2, and with the weightage, with we are summation this part. Again the bias is there, so 3 is the bias number, and we are putting this in the sigmoid function again, and we are getting the output. Yes. So capturing the non-linearity of the data, we are using the multiple perceptron. Yes or no? Please. So with the
Yes,
help
sir.
of the multiple perceptron, multiple layer perceptron, you can do the exercise. You can capture the non-linearity. Okay. For more understanding purpose, I just want to show you something. Okay, so this is the TensorFlow playground. You can means play with this thing. Okay, so I am taking different type of data. First, okay, so I am just telling you this is the learning rate कि कितने fast कितने slow ये भी change कर सकते हैं. This is the activation function. So here sigmoid is there, linear is there. So I can start with linear. Okay, and I am removing this layer first. Okay, what is happening? Just I am trying to teach you something. So hidden layer भी मैं हटा देता हूँ directly. Okay, so I am taking this data and learning rate is given to you. Activation function is linear. Then I am starting epochs. Epochs means अगर जो भी आपका एक साइकिल पूरा करने में समझ लो कि जैसे आपका एक epoch कब होगा फॉर अंडरस्टैंडिंग. लास्ट टाइम पे मैंने इसी में दिखाया, लास्ट स्लाइड में दिखाया था. हाँ, when we are doing this thing 0 0 0 1 1 0 and 1 1, so all this thing will run, then we will say one epoch is over. Okay, again the fourth thing will come, will done, then we will show that is the second epoch, third epoch, like this. So this is the cycle thing you can understand. Like now you can see some input x1 and x2 that I have given to you, and it will take I think more times. So इतने time आपका epoch चल रहा है अभी देखो, and there is somehow there is no change with the data, so that will be colored separable somehow. अगर ये नहीं होता मैं 1500 तक चलाऊंगा, उसके बाद स्टॉप कर दूंगा. सो इन अदर थिंग यू कैन सी. Okay, I think it will not linearly separable data directly because some data is here, some data is here. So if I am using this function, so I am stopping this part.
They
I can
kind of
use the
like chunk.
yeah. So somehow I am using the sigmoid कि कोई फर्क पड़ता है? I think यहाँ पे नहीं पड़ेगा. I have to increase the, okay, 2 neurons मैंने extra डाले. Now you can see what is happening. Somehow loss is means reducing some color functions. You can say some yellow part is coming in this part, some blue part is coming in this part. So somehow it is trying to means classify the data. Yes, again we are classifying the different type of data. अच्छा, यहाँ पे एक स्टोरी आपको अच्छी देखने लगेगी. These are, I am saying this is the neuron. You can see here some part is blue and some part is white. Some part is blue. और यहाँ पे देखो इस ग्रीन में ही देखो, इसमें देखो तो यहाँ पे एक सेकेंड मैं यहाँ पे एक रखता हूँ. अगर मैं इसको डिलीट कर रहा हूँ तो यू कैन सी, बिकॉज यहाँ से हटाते ही वो चला जाता है. सम पार्ट इज सो लीनियरली सेपरेबल. देख सकते हो एक पार्ट आपको व्हाइट दिख रहा है और सम पार्ट आपको ब्लू दिख रहा है. यस और नो? ठीक है. So again you can say this is the equation that one class is here and second class is here. In this part one class is here and second class is here. वही सेम मैंने समझाने की कोशिश की थी आपको जब आपको यहाँ बता रहा था. दिस इज नॉट द थिंग. या कहाँ गया, यही समझा रहा था. पीपीटी कहाँ गई? ओके, यहाँ पे जो समझाने की कोशिश की थी कि वन क्लास आपकी, हाँ दिस इज एक आपका ये लीनियर, एक परसेप्ट्रॉन ये है, ये ऊपर वाले पार्ट को दिखा रहा है, ये नीचे वाले पार्ट को, ये दूसरी लाइन है, एक वाले पार्ट को इधर दिखा रही है, इस वाले पार्ट को. तो वन पार्ट इज ब्लू एंड सेकंड इज ग्रीन, वो व्हाइट. वन पार्ट इज ब्लू एंड सेकंड इज व्हाइट. तो यू कैन सी हियर वन पार्ट इज ब्लू एंड सेकंड इज व्हाइट, वन पार्ट इज ब्लू और उसका कॉम्बिनेशन जा रहा है. सो यू कैन सी हियर दैट इज द कॉम्बिनेशन से आपको ये रिजल्ट मिल रहा है. इसको और आगे बढ़ाते हैं. इसमें ऐसा करते हैं, मैं लेयर और ऐड कर सकता हूँ. ओके, अभी मैं 2 न्यूरॉन्स की लेवल ऐड कर रहा हूं. Remember this thing, when you are going upper than the 2 layers, that is the deep neural network. Okay, some papers write आप 3 से ऊपर जाते हो और some paper writes आप 1 से भी ऊपर जाते हो, वो भी deep है, deep neural network. But ideally if you will say, if you are going to 2 hidden layers, upper than 2 hidden layers, you can say that is the deep neural network. Okay, now I am applying this same thing on this data. Now you have the, मैंने वहीं से स्टार्ट किया है. I think I have to stop this thing then. Okay, मैं इसको भी चेंज कर देता हूँ थोड़ा सा. हाँ, 10H ले लेता हूँ या रेलू ले लेता हूँ. सो बेटर रहेगा जल्दी समझाने के लिए. ओके, नाउ यू कैन सी this part, again this part you can see in the bigger picture, that is a linearly separable. This is also linearly separable. This is also linearly separable. So output जब आपका इन combination से generate होगा, you can see. अच्छा, मैं यहाँ के बाद बताऊंगा ये ऐसा क्यों आ रहा है. Just when you are taking, this is a linearly separable, but whatever the linearly separable data you have in this point, you are giving this data to the next one. So यहाँ पे डेटा और ज्यादा रिफाइन होता जाएगा और ज्यादा नॉन लीनियरिटी को कैप्चर करेगा. सो द मीन्स द बेसिक थिंग इज दैट कि when you are introducing the hidden layers, you are capturing the more non-linearity of the data. Yes, that part is clear. Even though you are in this layer, you are increasing the neurons, you are capturing more linearity. Now अभी देखो मैंने एक layer को बढ़ाया. Now your data is more clearer than the last one. Okay, so वो generate होके आपको इस तरीके से generate कर रहा है. Clear? This is the combination of this one and this one, whatever. जो सभी के input आपको जा रहे हैं वो वहां से data इस तरीके से हमको generate कर रहा है. So every time, अब मैं इसके इनपुट को चेंज करूं, चलो इस टाइप का इनपुट लिया, सेम अगर मैंने अप्लाई किया है, सो व्हाट इज हैपनिंग नाउ, वी विल ट्राई. सो अगेन, सो यू आर एबल टू कैप्चर, बट रेलू की जगह अगर मैं यहाँ पे लीनियर सिग्मॉइड कर देता हूँ तो मे बी उतना अच्छा कैप्चर नहीं करेगा. So somehow these are the points. If you are taking the activation function, what is the learning rate, what is the regularization, somehow जब डेटा को हमारा आएगा डिफरेंट टाइप का, तो रेगुलराइजेशन भी करते हैं कि एरर को और रिड्यूस कर पाए. So now you can see when I am using the ReLU, that is the more accurate, but when we are using the this sigmoid, वो आपके epoch ज्यादा ले रहा है डेटा को जनरेट करने के लिए, उसी डेटा को क्लासिफाई करने के लिए. तो somehow this is the story कि आपका डीप लर्निंग में किस तरीके से नॉन लीनियरिटी को वर्क करता है. यहाँ पे मैं हिडन लेयर्स को और जल्दी बढ़ा दूंगा तो मे बी सम टाइम डेटा को और जल्दी कैप्चर करे. यस, न्यूरॉन्स को बढ़ाने में, बट एवरी टाइम दिस इज द स्टोरी कि आप ये नहीं कह सकते कि मैं ज्यादा हिडन लेयर्स रख दूंगा तो आपका जल्दी डेटा कैप्चर हो जाएगा. दैट इज नॉट द स्टोरी. अगेन दैट इज डिपेंड ऑन द डेटा कि आपका डेटा किस तरीके का दिया गया. नाउ आई एम टेकिंग डिफरेंट टाइप दिस स्पाइरल डेटा. देखो ये डेटा और टफ है. दिस इज द टोटली नॉन लीनियर डेटा. इसके लिए शायद मुझे 10H को भी लेना पड़ेगा और न्यूरल नेटवर्क, मैं आपके न्यूरॉन्स और भी बढ़ा देता हूँ. यस, इसमें भी बढ़ा देता हूं तो देखें कैप्चर करता है या नहीं करता, किस तरीके से कैप्चर कर रहा है. ट्राई टू अंडरस्टैंड. तो इन द फर्स्ट लेयर एवरी टाइम यू कैन सी दिस इज द लीनियरली सेपरेबल. इन द सेकंड लेयर बिकॉज दिस इज द आउटपुट ऑफ लीनियरली सेपरेबल, समहाउ यू कैन सी कि आपकी नॉन लीनियरिटी को ज्यादा पकड़ रहा होगा, ज्यादा कैप्चर कर रहा होगा. तो इन एवरी स्टेप व्हेन यू आर इंक्रीजिंग द लेयर, नॉन लीनियरिटी को ज्यादा कैप्चर करने की कोशिश करेगा. यस, everyone is clear on this point? So you can play with this data and other things. So this is the story, what is happening. Try to understand in which layer what is happening. In the deep neural also you can understand now. So the basic thing is that if you want to capture the non-linearity, you have to go for the multiple layer of the perceptron, or you can use the different hidden layers also for capture the more non-linearity of the data. Everyone is clear on this point? Somehow देखो 1000 के बाद भी या 1000 epoch हो चुके हैं, even though it is unable to capture this thing. तो हमें और मैं hidden layers को बढ़ाता हूँ. Okay, so somehow it may work कि hidden layers को और बढ़ाया और इसको भी बढ़ा देता हूँ. So maybe I am not saying that is assure. I am not assuming that it will take or it will capture the data, but somehow because the more neural network it is there, so more nonlinearity should be covered with this thing. अभी भी epoch काफी लेगा I think. So you can see, yeah.
लेयर को हम टॉप बॉटम दोनों से हाइड उसको कर सकते हैं.
किससे? लेयर को टॉप बॉटम मतलब
जैसे आप मतलब उतनी कि जैसे कोई डेटा सेट है उसमें लेयर है तो नीचे से भी लेयर को हम हाइड कर सकते हैं क्या उसका, जब ईपॉक रन करते हैं तो.
हाइड समझा नहीं, यहाँ पे नहीं समझा मैं. व्हाट इज द मीन्स ऑफ हाइड?
हम लोग उसको हम कमेंट कर सकते हैं जैसे मतलब
प्रोग्राम में.
हाँ, नहीं रन कराना उसको तो
प्रोग्राम में, हाँ, वो ड्रॉप आउट और वो हटाने का अर्ली स्टॉपिंग ड्रॉप आउट, वो सब फंडे हैं. मतलब किसी एक को रन नहीं कराना, क्या है वो, दैट इज द प्रोग्रामिंग थिंग इज डिफरेंट.
यही प्रोसेस होगा ना उसमें भी.
प्रोसेस तो यही मतलब वहां पे बढ़ा सकते हो, घटा सकते हो. या okay, somehow it is not even captured, so somehow this is more non-linear data. तो I have taken some example, आप लोग different example पे use करके देखना and try to understand. That is not the thing कि आप programming करोगे whatever. This is the thing कि intuition क्या है, why we are using this thing and how you can means capture the data, what is the mechanism behind of this story. Yes, तो एक intuition मैंने दिया है. Now the multiple layer perceptron is covered. Now intuition is okay with everyone? Yes, this part is okay with everyone. Programming I will teach you in the next
Yeah.
class. जब भी मैं होगा तो मैं बता दूंगा आपको. Programming में आसान है, इसकी और आसान पड़ जाती है. Don't worry for that. Okay? जो नॉर्मल आप करते हो उससे भी आसान है. एक बार एक कोई अगर मॉडल बना लोगे, यू कैन गो फॉर एवरी मॉडल. थोड़ा थोड़ा चेंजेस करने होते हैं. But intuition, what we are doing, that is the important. Okay. Now, one more important algorithm is for the ANN purpose. You can say that is the back propagation. Okay. So आप लोग बताओ कि आज ही कवर कराऊं या नेक्स्ट क्लास में? बिकॉज अब तो क्लास अगर होगी तो आपकी मेरे ख्याल मिड सेम के बाद ही होगी. यस,
नेक्स्ट में ही करा 2:30 बज गया. नेक्स्ट में ही करा दीजिए
अच्छा,
सर.
यस तो अभी एक ही घंटा हुआ है. एनीवेज
कर सकते
आज
हैं हम
के
वैसे.
समझो. ओके, आज ये समझो, ठीक है. इसके छोटे कोई भी ANN का एक प्रोग्राम निकालना, समझने की कोशिश करना. ओके, व्हाट इज हैपनिंग. ओके, तो इसकी प्रैक्टिस करो. इन द नेक्स्ट क्लास वी विल सी द बैक प्रोपेगेशन एंड सम अदर डीप लर्निंग के कंसेप्ट कि डीप लर्निंग को कैसे यूटिलाइज करते हैं. यस,
सर.
ओके. सो आई एम स्टॉपिंग द रिकॉर्डिंग फर्स्ट. एक क्लास मुझे भी